So I wanted to finish up just an introduction overview here to logs in section 5.5 with just some examples. So for example, if I have log base 10 of 1 over 100,000, there's a couple ways I can look at this problem. One way would be to rewrite it immediately and use one of the first rules that we looked at. I'm going to rewrite it as log base 10 of, now 1 over 100,000 is going to be 10 to the negative sixth. So using our first rule that we learned, one of our first rules that we learned, is that answer is simply going to be negative 6. I also could have looked at the first expression up here and said, okay, if I look at this up here, 10 to some power equals 1 over 100,000. You say, okay, well 1 over 100,000, that is 10 to the negative sixth, therefore I'm looking at an answer of negative 6. So how about we have something like natural log of 1 over e cubed. Again, remember that natural log implies that you have a base of e. That's what that notation means. So I can rewrite this as natural log of e to the negative 3, and my answer is negative 3. Again, in the original problem, I could have viewed it as e raised to some power equals 1 over e cubed. So that's fine. E raised to some power equals 1 over e cubed. By inspection, that's negative 3. So how about log base 11, 1? How can I simplify that and rewrite that? A couple ways. One way is I can think it through. 11 to what power equals 1? Say, okay, 11 to the 0 equals 1, so I can simplify that as 0. Or I can actually do it in writing. Log base 11 of 1 equals something. 11 to the something equals 1. Clearly, if I raise 11 to the 0th power, that's the only way that I'm going to get a 1 out of here. So suppose you're giving something like natural log of x equals 2. And you're asked to solve that for x. By definition, e, natural log means a base of e, 2, e squared equals x, and I'm done. How about, for example, log base 5 of x equals 25. 5 to the 25 equals x. Whatever that is, I'm done. How about log base x to the root 6 equals 1/2. Solve for x. So if I look at this, then I'm looking at x to the 1/2 equals root 6. I want to solve for x. I could square both sides. Therefore, x equals 6. Now, you're also going to use your calculator a fair amount with logs if you want to get decimal approximations for things. For example, if I've got 10 to the x equals 60, I know that that's going to be, let's see, 10 squared is 100, too big. 10 to the first is 10, too small. So I'm guessing that x is going to be a number in between 1 and 2, closer to 2. Since 10 squared 100 is closer to 60 than 10 to the first, 10 is closer to 60. So, how do we solve this with a calculator? Well, I got two ways. One way, I certainly could put 10 to the x into y1 and 60 into y2, find an appropriate window, and see where the two graphs, 60 and 10 to the x, intersect. And that would look something like, here's my 10 to the x, and here's my 60. Find that point of intersection. That x value will give you an answer. There's a more direct way to do it if we use our definition of logs, less button pushing. And if I rewrite this expression 10 to the x equals 60 as log, and since it's base 10, I'm not going to write that 10 down there, log of 60 equals x, because I then know that 10 to the x equals 60 by definition. I then, on my calculator, can simply go and plug that in, type that in. I've got a log key on my calculator, and when we grab our calculators and hit log of 60, we get about 1.778. Indeed, a number between 1 and 2, closer to 2. One more similar to this. Let's suppose we have e to the x equals 42. Remember that e is an approximate, e's exact value is a non-repeating, non-terminating decimal, but it's about 2.71. So what I'm looking at here is roughly some number around 2.7 raised to what power is 42. And I might be able to do a guesstimate with that, thinking about, 2.7 is around 3, a little less. 3 cubed is 27. 3 to the 4th is 81, so somewhere maybe 3 to 4, somewhere in there. I've overestimated e to be 3, but maybe somewhere in there. I could do it, as I said, look at a graph of e to the x here, look at a graph of graph of 42, find that intersection point. That x value will be found using your calculator and your graphing mode. But I can do this again more directly by simply saying, hey, by definition, the natural log of 42 equals x, because I'm looking at e raised to the x is 42. And when I go ahead in my calculator, I have a natural log key as well. Natural log of 42 is about 3.737. About 3.737.